Harada has then found a way, or at least put to use a way, because probably the concept existed before, but it needed to be applied to something called adaptive indexing. Whereas I understand it, you even choose what kind of index to use depending on how the data is structured. Is that right?
Yeah, sure. So just to give you like the where we are. So RAD is a middle tier that sits between data and data consumers, mostly on the cloud, and mostly on data lakes, because this is where the most of the complex and hard and large and diverse big data comes to, at least on cloud environments.
Yeah.
And as that middle tier, our job is give you fast performance, give you that efficiently, and give that for workloads who are hard to model in advance. Because if you could, then you might just build data pipeline just for that.
Yeah. Essentially, this is like the known unknowns and unknown unknowns problem, right? If you know already in advance what you don't know, you can structure it. If not, then you have to throw money and resource at it.
Yeah, sure. So I prefer the word predefined, not predefined, because sometimes you know what you get when you get, but you can't. The problem is too complex to define that in an efficient way. Yeah. So this is the type of workloads we tackle, and as I said, the only alternative here is either go and model everything, which is not possible when you get those kind of workloads, or brute force your way.
Yeah.
So the technology that we do combines two very strong and different forces into one that gives that ability.
Yeah.
They are adaptive indexing, which I'll talk about as you asked, and workload analysis. So I'll start with adaptive indexing. Historically, there are indexes being used in data for quite a bit of time. Mm-hmm. But once we moved in the world of big data, you don't see the traditional types of indexes appear. There are many technology reasons to that. A lot of them related to the fact that data for analytics is stored in a columnar way. So it's related to how you store that data to be efficient to process it. And the fact that the way people can index big data today is just by sorting it on something and duplicating everything, which is, again, not really possible when you have so much data. You have a petabyte of data, you're not going to duplicate that a few times for just different types of queries. So it's a very hard problem to solve, because you have to deal with uncertainty of what the data is. You have to deal with uncertainty of how it grows. And you have to deal with the fact that there's so much of it that where you get a new piece of data, you can't really update anything behind. You can't do any garbage cleaning, any vacuuming. You have to keep the pace.
Yeah.
So our adaptive indexing technology doesn't exactly that. So let's just consider for simplicity you got a piece of operational data. It doesn't really matter how many rows it have or how many columns it have. Or as a goal, it shouldn't matter. Mm-hmm. So what we do is we have this layer. It's based on SSDs. It's a cache for those indexes, which leverages how SSDs work to deliver that. We break the data into very small parts. We call them a nanoblock. But essentially, it might be a few kilobytes mm-hmm. Of a column, of piece of a column. And this might be a very small piece, might be like say 60,000 rows of a column. And then for that very small piece of data, and think about if you have this 100 terabyte of operational data, that's millions of those pieces. So for one small piece of the data like that, we build an index just for it. Now that index, the way it's built and how it does, really depends on the contents of the data in just that piece.
Yeah.
If you have this column, it's a temperature sensor, and it's between 70 and 72, then you've got an index for that for a numeric range of 2 degrees. Mm-hmm. You've got the user ID, which is high cardinality, a GUID, you got an index for that. You got text data, you got an index for that. And as your data changes, because it does, both in the data types, in its contents and distribution, in what people ask of it, which just goes to more workflow analysis.
Mhm.
But as data changes, just a bunch of new blocks.
Mhm.
So you get this, we think about it as a mesh, a graph of millions of small indexes. Each one of them is optimal for a small part of the data. It's entirely adaptive because each one of them is unique.
Yeah.
It's entirely dynamic because each one is independent of the others. So if data changes, new data comes in, data gets deleted, there's very, very small impact. So just building a nano block.
Yeah.
And now every query becomes a walk or run across those small indexes.
Yeah.
Which is also a bit kind of a brute force, but a brute force at a very different level. We can, instead of having run across 100 terabyte of raw data,
Yeah.
we can have run on a million indexes, which are small SSD pages, and do that at 100th of the time for the same query, and do that without knowing in advance where the query going to take us. What columns do I care about? What I do with it? Because it's fully covers, and again, it's adaptive to how the data looks like, and dynamic to how it changes. So this is a very big part of it.
Yeah, so it's basically breaking the problem down into smaller problems and dealing with that. I guess there's a few advantages there, of course, that each of the smaller bits is more manageable. Plus, you can do a lot in parallel, and you can do them independently of each other, right? So rather than swallow the entire, what do they say, eat the whole elephant, you just start with a bite, right? That makes a lot of sense. And basically turning big data into lots of small datas.